But first, let's begin by adding the simple ones. So let's begin with the chop sounds. This is super simple. We just need to go over here onto the cutting counter, and actually we already have the onCut event that we made previously. This was used to spawn the visual, so we can also use it to spawn the sounds. However, there's actually one difference. We're going to have multiple cutting counters, and this one, as you can see, this one is not a static event, meaning each different counter is going to have each list of listeners, and we really don't want to have to subscribe to every single one of the counters individually. So what we can do is, instead of making it a regular event that belongs to each instance of a cutting counter, we can make a static event which will belong to the entire class. But we still want to leave this one just for the visual, so let's do another one, a public static event handler, and let's call it onAnyCut. Basically, for any static events that belong to any object type, I like to add the keyword any. We're going to fire this event when any cutting counter is going to trigger a cut action. So where we fire this event is exactly the same thing. So over here we've got the onCut. Let's do the exact same thing. So on any cut with this and event args.empty. Okay, so we have our nice static event. Now over here on the sound manager, let's listen to it. So let's go into the cutting counter. Again, we're going to access through the class name, and let's listen to the onAnyCut event. And over here, let's just play the sound. So let's play the sound. Let's go inside the audio clip refSSO, and let's grab the chop sound. Then for the position, we want to know who fired this event, and by following the C# standard, over here we already have the object sender. So we know this was the object that fired this event, and we know this is going to be of type cutting counter, so we can just get cutting counter, and we just grab the sender as a cutting counter. Okay, so we have this, and then over here, very simple, access transform.position. Okay, that's it, great. That will play the cutting sound on that position on that cutting counter. Okay, great. Now let's handle the player picking up something, and for that let's go over here onto the player class, and the way we set up the kitchen object parent system is actually already perfect for this. Down here we have a function, so if we scroll down, yep, this function, setKitchenObject. This one is called whenever the player receives a kitchen object, which means really when the player picks up something. So if this kitchen object is not null, then that means the player picked up something, so let's do that. So up here let's make the event. So a public event handler, call it onPickedSomething, and then down here just do a test. So if the kitchen object is not null, so if the player did pick up something, then let's just fire off this event. So just do our usual invoke with this and event args.empty. Okay, so that's great. Then on the sound manager, let's just listen to it. So let's go into the player class, let's access the static instance, and let's listen to the onPickedUpSomething event. And again, let's rename this to a proper name, so player onPickedSomething. And over here, let's just play the sound. And for the sound, go into the refs and grab, in this case, the object pickup. And for the position, let's just go player.instance and grab the transform.position. Okay, that's it. Next, for item dropping. Now we can only drop items on a counter. So over here we have the base counter class, and again we have the same thing, so we have the setKitchenObject. And again the same thing as with the cutting counter. We don't want to be required to listen to every single counter, we just want to listen to one event, so let's make it up here. So a public static event of type event handler, and let's name it on any object placed here. And then down here when we have the setKitchenObject, we do the usual if kitchen object is not null. If so, then let's fire off this event. Okay, great. And on the sound manager, let's listen. So go into the base counter on any object placed here. When that happens, play the sound. And let's go into the audio clip refs. And this one is the object drop, so that one. And for the position, let's do the same thing we did. So we cast the base counter equals the sender as a base counter. And then we go into the base counter and let's grab the transform.position. Okay, so we just need one more special counter type. Here we have the trash counter, and this one, it never really changes the parent, it just destroys the object. So over here on the trash counter itself, let's fire off an event. But again, let's make it static, even though we're only going to have one trash, but make it static just to be able to support multiple. So public static event handler on any object trashed. And then over here, just fire off this event. So invoke with this and inventars.empty. Okay. So now if we go into the sound manager, and over here, once again, the trash counter on any, not the on any object placed, but on any object trashed. And on this one, let's do pretty much exactly the same thing. So let's copy this. The sound is going to be the trash sound. Instead of a base counter, we could just cast it to a base counter, but let's make it proper. So let's make a trash counter as a trash counter, and this is a trash counter. Okay, great, that's it. So these are all of our basic simple sounds. As you can see, all the logic is super simple. So let's test and see if it all works. Okay, so first of all, let's pick up an object. So if I go into a container and I pick it up, and if there you go, there's the sound. Now if I drop it somewhere, and if there's the sound. Now for the trash, pick it up, drop it on the trash, and if there's the trash sound. Okay, great. Then also let's check out the cutting. So if I pick up some cheese, drop it there, and cut, and if there you go, got a really nice cutting sound. Okay, so far so good. Now let's handle the more complex ones, starting off with the stove. For this one, the sound is meant to be looping, but only when the stove is on, so we don't want to just play once, but play and stop playing depending on the state of the stove. So for this one, instead of spawning the sound through code, let's actually spawn it on the object itself. So let's go inside the stove object, let's go on the stove counter and open up the prefab, and inside this prefab, let's create a brand new empty game object, name it sound. Let's reset transform, make sure it's on 0, 0, 0. Okay, great. Now let's add an audio source component. And for the audio clip, let's use the pan sizzle. Let's make sure to not toggle play on awake, but we do want it to loop. And let's also make it a 3D sound. Okay, so that's the basic setup. Now to control this, let's make a script. So let's go into our scripts folder and let's create a brand new C# script. Call it the stove counter sound. Let's attach the script over here and let's open it. So now here first let's grab the audio source component. So we've got a private audio source for the audio source and just go on awake and audio source equals get component of type audio source. Okay. Then we're also going to need a reference to the stove counter. So let's add up here a serialized field, private of type stove counter for the stove counter. Then back in the editor, let's drag that reference. All right. Now on the stove counter, over here we already have the states and we have the onState change event. Again, the same one that we used to modify the visual. So on the sound, let's do pretty much exactly the same thing. Over here, let's do a private void start. And on start, let's go into the stove counter and listen to the onState changed event. And basically, when this changes, we want to check if it's frying or fried. If so, then we want to play the sound. If no, then we don't want to play it. So let's define a bool, call it play sound. And we're going to play if the state equals we are frying or the state equals that it is currently fried and about to burn. Okay, then if we have a play sound, then let's go into the audio source and call play. And if not, then let's go into audio source and call pause. All right, so that's it, pretty simple. Let's just make sure to save our prefab, go back outside and let's start on play. And okay, for stars, there's no sound playing. Now if I pick up some meat and I drop it on there, and if there you go, there's the sizzling sound and continues going, and now it is still sizzling, but if it burns, it should stop. So if I go, and if there you go, the sizzling sound stopped. All right, awesome. So let's take this one out. Let's actually trash it. Now let's pick up another one, let it cook. And once it's cooked, pick it up, and there you go, the sound does stop. All right, awesome. So we just have one more final sound remaining. That's the footsteps. By the way, the warning sound is going to be added during the polish lecture. For the footsteps, we want very much the same thing that we did on the stove. So we're going to want a script to handle that logic. But this time we don't need an audio source on the player. We're going to use the same play method as the other ones. Let's just make a script to run the sounds. So let's make a new C# script for the player sounds. Let's go into the player game object and attach the sound. Okay. So now here, let's first grab the player reference. So private player, and on private void awake, let's get component of type player and assign it to the player. Okay. Then for the footsteps, basically we want to play them every certain amount of time. So let's do up here a private float for the footstep timer, another one for the footstep timer max, and let's say we want to play, say, 10 times per second. Then we do a basic update, and on update, footstep timer, countdown by time.delta time, And if the footstep timer is under 0, then let's reset it, so set it to the maximum. And it's in here that we're going to play the sound. So now here we have two options. We can fire an event here and we can listen to it on the sound manager. So exactly the same thing that we've been doing previously. Or we can just trigger the sound directly from here. Doing that will mean that this class is tightly coupled with the sound manager. Usually we want to avoid tight couplings. However, in this case, the player sounds class, this one is really only meant to exist alongside the sound manager. So in this case, it's perfectly fine to tightly couple them. So let's play the sound directly from here, which means we need a reference to the sound manager. We could make a serialized field or just make this a singleton, so let's do that. So a public static type sound manager. Name it instance with a public get and a private set. Then on private void awake, we just set the instance equals this, okay? So then over here we can just access it. So just go into the sound manager, access the instance, and we call play sound, which we actually need to make public. However, this function also takes a reference to the audio clip array. So that means we need a reference to the audio clips. So again, we have multiple options. We could add over here on the player sounds, add a serialized field for the footstep sounds, or we can just make a specialized function over here on the sound manager. Both options can work just fine. Let's go with the second one just to be different. So just make here a public void play footstep sound. We're just going to receive a vector 3 for the position, and then we just call play sound. Let's go into the audio clip ref.sso, and let's pick up the footsteps and play it on this position. And let's also receive the volume. Just up here a float for the volume. Okay, so that's great. Now we just need to call this function. So over here on the player, instead of calling play sound, let's call the other one play the footstep sound. Then for the position, that's the player transform.position. And for the volume, I just exposed the volume just in case you want to make the footsteps a bit more silent or not. But for now, let's begin with 1F and then see if that's way too loud. As usual, instead of using magic numbers, let's define a float for the volume, put it at 1F. And over here, use the volume. Okay, great. However, you might be noticing an obvious issue here. Right now, this is going to play non-stop. Obviously, we don't want to do that. We only want to play footstep sounds if the player is actually moving. So this is pretty simple. We just need to ask the player if it is moving. And we already did that. So player is walking. So if the player is walking, then we play the sounds. If not, we don't. Okay, that's it. So let's test. So here we are, and if I'm standing still, there's no footsteps. Okay, that's great. And as soon as I move, yep, there you go. We got some nice footstep sounds. All right, great. So with all of that, we added all of our sounds. Now here, note how we mostly use this method of going into the audio source and using the play clip at point function. This one is great because it is so simple, but it does have limitations, specifically with regards to all of the options. If we look on the audio source component, here we have all these options. So you can use an output, use an audio mixer like we saw in the previous lecture. We can play around priority, play around the pitch, make it 2D or 3D, play around over here with how the sound falls off. So tons and tons of options that you can't really access if you use that simple function. So one approach, if you need these options, you could make each sound a prefab. So make a prefab for each different audio clip. And then instead of calling that function, you would simply instantiate that prefab to spawn that audio. So you've got lots of options depending on how complex you want your sound to be. But for a simple game and for simple sounds, this one line of code is super simple. Alright, so here we have added sound effects to our game. That coupled with the music that we added previously already makes everything sound so much more alive. It's really starting to look like a proper game. The one thing we still don't have is some kind of game start and game end scenario, so let's add that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, let's add a simple beginning state to our game. So right now we can play the game. All of the mechanics, everything works perfectly, it's all been implemented. However, in the beginning of the game, it just starts right away as it loads. There's no start, no countdown, no time for the player to get ready. So let's sort that out with a simple countdown. Let's begin by making a general game manager script to handle all of our general game states. So let's create a brand new C# script. And now here you could use the name game manager, so you could use this name. However, for some reason, Unity likes to add this custom icon when a script is named exactly game manager. Personally, I don't like this. I don't want it to be a different icon. I want this script to look and behave just like any other one of my scripts. So personally, I don't like this, but if it doesn't bother you, then go ahead, use it. Doesn't really change anything, just a visual. But in my case, I prefer to give it a different name, so sometimes I call it Game Handler, or other times just something related to this game, like for example the Kitchen Game Manager. And just like that, it won't have that custom icon. Just need to go inside and rename this to Kitchen Game Manager. Okay, save the script. And alright, now let's make a game object to run it, so a new game object with the same name. Let's attach the Kitchen Game Manager and reset transform. Okay, let's open. Now here we're going to define all of the various game states that our game can be in. So for that, let's define an enum. So a simple enum, call it state. And for the various states, let's say we are first of all waiting to start. Then we are on countdown to start. Then the game is playing, and then we have a game over. Okay, so these are our states. Let's do a private void awake. And on awake, let's set the state. So we need to store a state for our state. And on awake, we set the state equals, and let's begin on waiting to start. By the way, the point with this waiting to start state will also be very important in the next video covering multiplayer. Basically, we're going to wait until everyone is connected before we start the actual countdown. But over here, for now, we're just going to wait a little bit on the waiting to start. Then we're going to trigger the countdown, and then after some time, trigger the game playing state. So pretty much all of these states are going to be time-based. So let's make a simple timer. So a private float for the waiting to start timer. Let's begin on something like 1F. So we just wait for 1 second. Then let's make a private void update. And let's make a state machine just like we've done previously. So do a switch on our state. In case we are on state.waiting to start. If so, then let's go into the waiting to start timer, count it down by time.delta-time. Then if the waiting to start timer, if it is under 0. If so, then let's move into the state, equal state dot, let's go into the countdown to start. Okay, so that's it, and the other states are going to be pretty much exactly the same, so let's just copy this. So we have the waiting to start, then the countdown to start, then we have the game playing, and finally we have the game over, and that one doesn't have anything, so just like this. Like I said, we could reuse the same timer, but let's write our code nice and proper, so let's make different timers for each. So let's make 3 timers. So we're going to have the countdown to start timer. So countdown. For this one, let's default into 3. So we're going to wait 3 seconds before we start. And then the game playing timer. And for this one, let's put it something short just for testing. So let's put it just test. And then down here, let's just use them. So on the countdown, let's count down this timer. On the game playing, count down this timer. When the countdown ends, we go into game playing. And when the game playing ends, we go into game over. Alright, so that's our super basic state machine. Just a bunch of timers, super simple. Let's do a quick log just to see. So over here, just a debug.log, and let's just print out the current state. Okay, so just like this, let's test. And yep, right away we are waiting to start. After 1 second, going to countdown. Then after 3 seconds, going to game playing. And now if we wait for 10 seconds, after 10 seconds, we should be able to see just a little bit. And yep, there you go, we've got our game over. Okay, great. All the logic is working. Although we actually didn't change anything. Technically the game right now is on a game over, but everything still works the same as previously, so I can still play, I can still do everything. So let's sort that. When we are in any state other than the game playing state, we don't want the player to be able to interact with anything. We want to leave it movement, because that's usually nice and fun, but we don't want it to be able to interact, pick up objects, or do anything, so let's do that. Basically over here on the game manager, let's just expose a function, so public bool, let's call this is game playing. Then over here, pretty simple, just return if the state equals state.gameplaying. That's it. So now we can go into the player script. So over here on the player script, let's go down into the interaction function. So over here we've got the interact alternate and the interact. And on both of these, basically let's just ask if the game is in the game playing state. If so, we want to interact, but if not, then we don't want to do anything. So to access the game manager, we could add a peer serialized field, or as usual, let's just make a nice singleton. So peer public static of type kitchen game manager, the instance, make a public get and a private set. Then down here on awake, let's set the instance equals this, okay? So now over here on the player, let's just go into the kitchen game manager, access the instance and test is game playing. And we're going to do an if the game is not playing. So if we are not playing, we want to stop this, so let's just do a return. So if the game is not playing, the code is going to stop executing here, and same thing on the interaction. So just like that, we won't be able to interact with anything once we are not in the game playing state. Okay, so here we are, waiting to start. Nope, I cannot pick up anything. Countdown to start. Nope, I can't. And as soon as we go into game playing, yep, now I can't interact, so I can cut a bunch of things. And as soon as it goes into game over state, there you go, currently in game over state. So now if I try to interact, nope, can't do it. Okay, awesome. Everything works perfectly. So in terms of logic, this is really it. There's nothing else we need to do. But of course, right now the player would have no clue as to why sometimes they can grab and sometimes they can't, so let's add a proper visual. First, let's add a visual to the starting countdown. So let's do that as a canvas element. So let's go inside our canvas, create an empty game object, name this the game start countdown UI. Let's press F to focus on the object, press 2 to turn this into 2D. Okay, so let's see. Now over here, we really just need a text object, so let's leave this one anchored on the center. Let's put the width and height both on 0, we don't need that. And then let's go inside, create a new text object, call this the countdown text. And then inside, let's just put a number, so just a 3. Let's put the width and height both on 0. Then down here, let's put it in bold on a really big font size. So let's say something like 250, okay, really nice big number. Then let's also put it centered and down the middle. Okay, that's great, we've got our nice big countdown number. Also, by the way, when using Text Mesh Pro, we can easily add a whole bunch of effects. If we look down here, we have the default Text Mesh Pro material, and over here we can add an outline, an underlay, and so on. So that's really great. However, there's one very crucial thing. When you want to add some effects, always remember that the effects are being applied to the material, meaning any text objects that are sharing this material, all of them will modify. So for the most part, usually you don't want to modify the default material. If you do, then everything using this default material will change. Like for example, I want to add a nice thick outline to this one, but over here I've got some regular text that is also using the default material. So if I now add an outline, and I increase the thickness, and if there you go, those also got an outline as well as this. And if I want to dilate and make it quite a lot bigger, there you go, all of them modify, because all of them are sharing the same material. So usually you don't want to modify the default material. If you want to add some kind of special effects, always make sure to create a brand new material beforehand. So over here, let's remove the outline, put it back on the dilation, and let's go up here to create the brand new material. First, we need to find our font. So over here on the font asset, we can just click on it, and we can see it over here highlighted on the project window. So it's inside the Text Mesh Pro folder, the resources, fonts, and so on. So here is the default font, and inside this one is the font that we're using. Now in this font, there's a nice little arrow icon, and inside we can see the default material. So let's duplicate this material. Although it's important, make sure you duplicate the material and not the font. So with this material selected, I'm going to press Ctrl D, and there you go, it duplicates the material. And over here, let's give it some name. So let's say this is the material that I want to use for the start countdown. So there you go, just like this. Also, one very important thing, the name of the material needs to include the font name, otherwise it won't show up. For example, if I get rid of this, the Liberation Sans SDF, if I name the material just like this, and now I'll look over here on the countdown text, look on Text Mesh Pro, here is the drop-down menu for selecting the material, and over here note how that one does not show up. So it is extremely important, in order for it to show up in here, it needs to have the same starting name. So over here, if I rename this material, put Liberation Sans SDF and then the name, and now back in here, now look, and yep, now I do see my material. Okay, so that's great. And now over here we can add what kind of effects we want, and it will only affect this one and not any others. Okay, so for this one, let's add a nice outline and let's make some nice thick numbers. So over here on the dilation, let's dilate by quite a little bit. Then for the outline color, let's put it maybe on a blue, something a bit like this. Okay, let's push it back just a little bit. Okay, I think that looks pretty good. Now, if you want, you could add even more effects to this. I made another video covering how to use custom textures in your font. Doing that, you can just import the font directly into Photoshop and edit it with all kinds of effects. For example, that method is exactly what I used in my game Hyper Knight to make the hit counter look really nice. I also have a tutorial specifically on that. So if you want even more custom text, definitely go ahead and watch those videos. But anyways, here we have our countdown text looking pretty nice. Now the number itself will be written through code, so let's do that. Let's go into our scripts, into our UI folder, create a brand new C# script for the game start countdown UI. Okay, let's select the parent object and attach the script. Now here, first thing we need is a reference to that text object. So let's add a serialized field, private. And again, remember what I mentioned a couple of lectures ago with regards to the types. So we want Text Mesh Pro UGUI, we want this one. So it's going to be our countdown text. And now for updating this text, basically we just need to know the game state. So we need to know when the countdown should show up. And as usual, let's use some nice events. So over here on the kitchen game manager, let's fire an event whenever the state changes. So a public event handler. Let's call it on state changed. Okay, just like this. No need for the arguments. So let's go down here. Whenever the state changes, let's just invoke this event. So invoke this event args.empty. So we change in there, and change down there. Okay, that's it. So now over here on the game start countdown, let's do a private void start. And on start, let's go into the kitchen game manager, access the instance, listen to the on state changed event. As usual, write some nice clean code. So let's rename this to the kitchen game manager. So when the state changes, we basically want to show this if we are on the countdown to start. So let's go here to the kitchen game manager and let's make another function. So public bool is countdown to start active. And we just return if the state equals the state dot countdown to start. Okay, so that's a nice simple function. And on the UI script, if the kitchen game manager, if this one dot is countdown to start active, if so, then let's show. If not, then let's hide. So else, let's do a hide. So let's make these functions. So private void show and a private void hide. And on this, let's just do the usual thing. So game object set active into true, or over here set it into false. And on start, right after we subscribe to the event, let's also hide it by default. Okay, so that's the basic logic for showing or hiding it. And now for the timer text. Technically over here, whilst inside the countdown to start, we could fire an event on every single update. That would work, but it would have some unnecessary overhead. So instead, another option is just make a function to expose it. So let's go here, make a public, return a float, get the countdown to start timer. And we just return the countdown to start timer, very simple. So then over here on the UI script, we can just make a regular private void update. And on update, go into the countdown text in order to set the text. And let's go into the kitchen game manager and let's get the countdown to start timer and just do a toString. Okay, so that's it, super simple. So on update, we're going to constantly update the timer. So let's see if this works. Back here in the editor, let's just make sure to drag the countdown text reference and let's hit on play. And okay, waiting to start, and after a bit, yep, there you go, there's the number. It's currently on countdown, and now the game is playing. So the show and hide did work, although the number seemed quite a bit odd. That's because over here on the settings, we have wrapping enabled. So let's just quickly disable this and let's test again. So there we are, waiting to start, and there you go, there's our countdown, 3, 2, 1, 0, and there you go, game playing. Okay, so it did work. Now of course, as it comes to the visuals, it depends on what you want. For example, if you want to limit the decimals, you can use over here the toString. This one can include all kinds of string formats. For example, for displaying just 2 decimal places, you can add the string format f2. Let's see what this looks like. Waiting for the countdown, and there you go. Now it does show with 2 decimals. Okay, so this is one approach. Alternatively, another format you can use is number sign, point, number. And let's see this one. And yep, there you go. Now it looks like this. So as you can see, there's lots of things you can play around with when it comes to the toString formats. But in our case, I don't really want any decimals. I really just want to see whole numbers. So for that, let's just seal out this number. So a mathf.seal. Let's seal this one out. And then just do a toString. Okay, let's see. So wait a bit, and we got 3, 2, and 1. And there you go, the game is playing. Alright, awesome. So here we have our waiting to start and the countdown to start. All of that logic is working perfectly. Now the next thing we need is to handle the game end, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to handle the game over state. Now for the game over state, this is obviously a game design question. For example, you could make it so that each recipe had a timer attached to it and the player had to create that recipe within the time limit. Then if they failed enough recipes, you could trigger some kind of game over. Or for something more simple, let's just do exactly what we did for the game start. Let's just do a basic countdown timer. After the game is over, let's pop up a game over window and show how many recipes the player delivered. So let's do that. Let's go into our canvas and inside make an empty game object. Call it the game over UI. Then over here, let's stretch it to occupy the entire parent, like this. Now inside, let's begin by making a UI image. This is going to be the background. Let's put it in black with just a little bit of transparency. And let's also stretch this to occupy the entire thing. So just like this. Then let's make some text. So let's make a new UI text. Call it the game over text. And let's say just game over. Let's set the width and height both at 0. Then down here, disable wrapping, put it centered. Let's put it pretty big, so maybe 135. Put it a little bit higher. Then for some more text, let's duplicate this. Let's call this the label recipes delivered text. And over here we just say recipes delivered. Let's put this one a bit lower and quite a bit smaller. Say on 50. Okay, and also on this one, let's put it in bold and change the color a little bit. Okay, next let's make yet another text. This one is going to be for the final number. So let's call this recipes delivered text. And this one is just going to have whatever number of recipes we delivered. And let's put it over here and quite a bit bigger. Okay, so this is the game over window that we want. Also, quick note, like I mentioned previously, the sorting order over here on the UI is based on the order in the hierarchy. So for the game over, we want this one to show up on top of everything else. So make sure the game over is the last one over here on the UI. Make sure it is the bottommost child on the canvas. Okay, now let's make a game object to run this. So let's create a brand new script. Game over UI, let's go into the object, wait for the compilation, and let's drag the script. Okay. Now here, the only reference that we need is just for the text. So let's just make a serialized field of type text mesh pro UGUI. For the recipes delivered text. Here in the editor, let's just drag that reference, okay? Now let's make some show and hide functions and also show it just on the game over. So really, we're going to do the exact same thing that we did over here on the game start countdown. So let's actually copy exactly this. Let's go into game over UI, pass the exact same thing. Okay, so we've got the show and hide functions, we test. And then over here on the state change, instead of showing this one on the countdown, we want to show it on the game over. So let's go over here and just make another function. So public bool is game over, and we just return if the state equals the state.gameover. Okay, that's the function. So over here, if we are is state game over, if so, then we show, if not, we hide. Okay, the last thing we need is just for the text. So this is going to be the recipes delivered text. So we're going to set this to something, which really means that we just need to keep track of all of the recipes that have been delivered. So let's go here onto the delivery manager script and let's just keep track. So just a simple int, so a private int for the successful recipes amount. And then whenever we have a recipe success, so let's go here into our delivery recipe function. Whenever we have a success, let's just increase this by 1. Okay, so that's it. Now we just need a function to expose this. So a public int for the get the successful recipes amount and just return the successful recipes amount. Okay. So finally, back here on the game over UI, let's just print it. So go into delivery manager, access the static instance, and get the successful recipes amount. And of course, we need a string, so toString. Except for this one, this is never going to change after the game is already over. So let's not do this on update. That would be quite wasteful. So let's just do it up here. So as soon as we have the game over, we print the recipes, and that's it. Okay, so let's test. So here we are waiting for the timer. And let's wait and just wait 5 seconds for it to finish, and we should see a 0. So let's just make sure that works. So after a little bit of time, yep, there you go. We've got recipes deliver 0. Okay. Now back here again, let's try to deliver some recipes now. So let's try to make a cheeseburger. Try to deliver that. Cut this one, pick up this one, pick it up, put it in there. And okay, quickly. All right, good. And there you go, we've got a 1. All right, awesome. Everything worked perfectly. Let's just add one more final element. Right now, we cannot see what is the time left in the game. So let's add a nice clock element. So over here on the canvas, let's make another empty game object. Let's name this the game playing clock UI. And let's also put it behind the game over UI. So let's put it above on the hierarchy so that it shows up behind. In order to be able to see what we're doing, let's also just hide the game over UI, but only here on scene view. So let's click on the eye icon. Okay, so here we have our window. Let's just anchor it on the upper right corner. So let's put it somewhere in there. Then inside, let's create a new UI image. Call it the background. For the sprite, let's go with the circle sprite. So let's click on the eye icon to show all the default sprites. And let's use the one included with the circle. So you have this one. Let's also add a nice little outline. So let's put it on 2.2 with full alpha. And let's also add a nice shadow, just a nice visual. So on 5 minus 5, like that. And for the color, let's also put it some kind of dark gray. Okay, so this is our background. Now let's duplicate this, so Control D. And let's rename this one the timer image. And for this one, let's give it a different color, so maybe something like a blue. So something like this, okay. And now over here on the image type, instead of simple, let's go with filled. Let's choose radial 360, okay, great. And now over here we can play around with the fill amount, and this will be our timer. Then you can set it up however you want. For me, I'm going to choose to start from the top. So as it starts, the timer is going to count down until the end. Okay, so that's great. Now let's make the script to run this. So let's create a brand new C# script. Same thing, the game playing clock UI. And over here, let's just attach a script. So now all we need is reference to our image. So let's make a serialized field. Private image, let's make sure to use this one, the image inside Unity Engine.ui. This is going to be our timer image. Okay, like this. Back here in the editor, let's drag the reference, all right. Now that we have this, we need to ask the game manager to get the timer normalized. So let's go over here onto the kitchen game manager and let's make a function to return just that. So a public float, let's call it get playing timer normalized, or game playing timer, actually, just to match the state. So get this one, and up here we have the playing timer. We just need to define a maximum in order to be able to calculate the normalized value. So let's duplicate this, call it the game timer max, and set this one to 10, and this one, leave it like this. And down here, when we change the timer, when we go into game playing, let's set this one equals this.max. That way we only define the timer just up here. Okay, so with that, now down here we can do the compilation. So we can return the game playing timer divided by the game playing timer max. Except just like this is going to be inverted, because for the game playing timer, we're counting down instead of counting up. So all we need to do is very simple, just reverse this. So just 1 minus, just like this. Okay, great. So we have this function. And then over here on the clock, just go private void update. And on update, let's go into the kitchen game manager, the instance. Let's get that. And we're going to use that on the timer image.fillAmount. Okay, that's it. Super simple. Let's see. Okay, here we are on the waiting to start. All right, waiting. And as soon as we start, yep, there you go. There's the timer going. And we can see it constantly increasing. So it's at the halfway point. And just a little bit more. And there you go. Yep, we've got the time over and we have our game over. All right, awesome. So over here, we implemented a really nice game over state. We have a playing timer with a nice UI element, and when it ends, we get a game over window showing a bunch of stats. Now with this working, the next task is to have some kind of main menu so we can play again after the game is done. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to make a super simple main menu and a loading system. Okay, so every game needs a main menu, so let's build one. Let's begin by making the scene, so let's go into our scenes and create a brand new scene. Call this the main menu scene. And okay, here's our default scene. Now over here, for the most part, we really just want some basic buttons, so nothing too special. So let's create a brand new UI canvas. And let's set it up as usual, so screen space overlay, yep. Then let's go with scale with screen size. 1920 by 1080, and let's match with the height. Okay, so there's our canvas. Now inside, let's make an empty game object, name this the main menu UI. Let's stretch it to occupy the entire thing, so 0, 0 on everything, okay. Now inside, let's create a brand new UI button. Let's name this the play button. Then inside for the text, let's say play. Let's size the button to be quite a bit bigger, so let's say 450 by 150. And on the text itself, let's put it in bold, on a font size quite a bit bigger, let's say 70. Then let's also change the color. Let's put the text in white and the play button over here, the normal color for the image. Let's put it on a dark gray. Then also over here on the button background, let's add a nice outline. Let's put it on full black, say something like 3:3. Then let's make a shadow. And for this one, 5 minus 5. Okay, so that's our basic button. Let's just anchor the button, so choose the play button. Let's anchor it on the lower left corner. And let's push it just a bit like this. Okay, pretty simple. Now let's duplicate this one, push it a bit lower. Let's also make it just a tiny bit smaller, so just 120. This is going to be our quit button, so let's rename this to the quit button. And inside for the text, just say quit. And put a bit lower on the font size, okay, like this. Okay, so we have the two basic buttons that we need. Now let's make the script random. So let's make a script with the same name, so main menu UI. So let's go into our script UI folder, create new script for the main menu UI. Let's attach the script and open. Okay, so now here let's begin by making serialized fields for our buttons. So a serialized field, private of type button inside unityengine.ui. This is the play button, and then we have another one for the quit button, okay? Back in the editor, let's drag the references, so that's the play button and the quit button, okay? Now here in the code, let's add some listeners to these buttons. So let's do a private void awake, and on awake, let's go into the play button and go into the onClick event. So the event when the player clicks on the button, and let's add a listener, and now we pass in the listener. Now over here, to do this, we can add a function, so we can make a private void play click. We can define a function kind of like this, and over here add it as a listener. So that's one approach. Or another alternative that personally I like to use is to use what is called a lambda expression. So instead of defining an external function down here, we just go up here and directly we define a lambda. So we open parameters to display the parameters for the function, which in this case we have none, so just open and close. Then we do a nice little arrow, and then we have whatever we want to be our click code. So both the code that I have here and the one that I have here, both of these are exactly the same thing. This one is called a lambda expression, which is also a type of delegate. Definitely go ahead and watch my video on C# delegates in detail. It's yet another extremely powerful C# feature. I find them especially useful, especially over here to setting the click listeners. There's no need to make another function, just use a lambda expression and that's it. So over here I'm going to use that instead of an external function. Okay, so we've got the play, and then let's also listen to the quit. So on the quit button, the exact same thing. Okay, now first on the quit button, it's actually very simple. We just go into application and we call the quit function. This will quit the game, that's it, very simple. Although one note, if we actually test it like this, so here is the game playing, and if I click on quit, and nope, nothing happens. Now the logic is actually working. We can see visually that the button is changing state, so we are indeed capturing clicks. However, when the game is running inside the editor, calling that function, the application.quit, doesn't do anything. But if this were a full build, then clicking on that would indeed close our game. Okay, so now for the play button. For this one, it's also very simple. We just need to go inside the scene manager, which is inside unityengine.scene management. We just need to go inside of this one, and we call load scene. This function will load a certain scene, and for loading, we can either use the scene build index or we can use the scene name. Like I've mentioned several times, string names are horrible, although in this case the alternative using an int is also not very good. Just a number is very hard to read the code and be able to know what scene this is loading. So there's one better approach that I prefer to use, but first over here let's just use the index just for testing. So we're going to load the scene on index 1, so just like this. And then here in the editor, let's go into File and Build Settings. And over here we see the scenes in our build. Right now we just have the game scene. So let's just add our scene. So let's drag the main menu scene and drag it on there. And also let's make sure it's on the top of the list. Basically the first scene is the one that will be loaded as soon as the game starts. So let's drag it right up top, just like that. Then over here on the right we see the index. So by loading the scene on index 1, we're going to be loading the game scene. Okay, so with this let's test. So here we are, and if I click on play, and if there you go, it does load the main scene. Okay, great, everything is working. So this is the simplest way to do scene loading. However, this method does have one issue. It's not super noticeable in a game of this scale because it loads pretty quickly. But like this, note how when we click on play, there you go, everything freezes for a little bit while the game is loading. Like I mentioned, in this case the freeze is so small, so not necessarily an issue. But if the game was much more complex, then the player would be staring at a frozen main menu for perhaps 30 seconds. That would not be good. One way to avoid that is actually very simple. Basically, it's what I already covered in detail in the scene loading video. That video was made quite a while ago, but it's still very much up to date. Here we're going to do pretty much the same thing. So we first create the scene, just empty, just saying loading. And then from that scene, we load the final scene. That way the game stays frozen on a scene that says loading, which is much more clear to the player. So let's do that. First, let's make our scene. So inside our scenes folder, let's create a brand new scene. Call this the loading scene. Okay, let's go inside. And now in this one, we want this one to be fully black. So let's go into the main camera and scroll down over here under environment. And instead of rendering the skybox, for the background, let's go with a solid color and let's go with full black. Okay, there's our black main camera. Now let's make a canvas. So a new UI canvas. Let's set it up as usual. So scale with screen size, 1920 by 1080 and match with the height. Okay. Then inside, let's just make a simple text object. So just say text, then over here, let's say just loading. Let's put the text width and height on 0, put it on bold. Let's make sure to disable wrapping and push it over there on the side and maybe increase the font size by a little bit. Okay, there you go. We have our very basic loading screen. Now we're going to load this scene, and then whilst on this scene, we're going to load the final scene. Although also one very important thing related to loading scenes is you need to remember the lifetime of the objects. Regular game objects, like for example the ones that we see here in the hierarchy, these get destroyed when you do a scene change. So for the goal that we're trying to achieve, we need to load this loading scene, but then also somehow transfer data so that the loading scene here knows which one is the final scene. Now you might think that over here on the main menu we could create a game object, attach a script that would hold the reference to the final scene, but like I said, game objects get destroyed as soon as we load the loading scene. So for transferring data between scenes, we can't really use a regular script on a regular game object. Now one approach is to use the don't destroy on load. This is a Unity function that helps you stop a particular script or a game object from being destroyed. That way the object won't persist through scene changes, so that's one option. But another option that I prefer is very simple. Let's just make a loader class. So let's create a new C# script, call this loader. And over here, let's go ahead and make this class a static class, and we are not going to extend mono behavior. So just like this. Basically, by making it static, it means that this one is not attached to any specific instance of an object. This class cannot be attached to any object and cannot have any instances constructed. Then inside we can add static functions and fields, like for example a static int for the target scene index. So now this field, we could set this field from over here on the main menu UI, and when we would load, we would not be resetting this field. Also here I should point out one quick thing. You can make fields static without making the entire class itself static. Making the class static is just a good approach if the entire thing, if everything in this class is also meant to be static. If you don't make it static, then you can have regular fields here. You can have both static and non-static. Whereas if you make this static, then you're going to have an error because you cannot have non-static fields. So this is another clean code thing. If it's only meant to contain static logic, then make the class itself static. Okay, so we have a static field for our target scene. But as usual, we don't want this to be a public field. We don't want the main menu to directly write to this field. So let's make this class the only one responsible for anything related with scene loading. So instead, let's make a function, so a public static void, call it load. And for a parameter, let's receive a string for the target scene name. Then over here, we'll load the actual scene. So let's go into the scene manager and load the scene. And let's pass in the target scene name. Okay, that's it. And then over here on the main menu UI, instead of directly loading a scene, let's go into the loader and call load and pass in the scene name, so that's the game scene. Okay, so this is what we're going to do, that's good. Except it's obviously not good. Over here we're using string names, that's horrible, we should never use this. So let's avoid using strings as much as possible, and one simple way is to just define an enum for all of our scenes. So let's go here on the loader and let's define that. So a public enum, let's call it scene. And for all of our scenes, so we have the main menu scene, then we have the game scene and the loading scene. Okay, so then down here on this function, instead of receiving a string, we just receive a scene for the target scene, and we use the target scene. Although of course the Unity API does not support loading our custom enum, it has to be an index or a string, so the simple approach is just to convert this one into a string, that's it. So the only thing you need to make sure is that the enum values over here match the actual name on the actual scenes perfectly. So don't make any mistakes, keep it case sensitive, so don't do this, make sure everything matches perfectly. Okay, so just like this, everything should already be working the same as previously. So the main menu calls that, let's actually just use that. So let's use scene.gameScene. So on the main menu we do this, and on the loader we load the scene. Okay, let's test. Here is the main menu, and if we click and wait a bit, and yep, there you go, it didn't load the game scene. Okay, great. So everything still works the same as previously, except now all of the loading logic is inside of this class. And over here, let's load a loading scene in the middle. Basically, when we have this function to load a final scene, let's first off set this field. So this one, instead of being type int, let's make it of type scene. And this is going to be the target scene. And let's make it private, okay? So when we have this function, let's set that field. Although here, remember how this is a static class, so in order to access this field, we need to access it through the class name, because over here we also have a local variable with the exact same name. So let's access the unloader.target scene and set it to the target scene. So again, don't be confused here. You can even use Visual Studio and put the cursor on top to see what object represents what. So you can see the unloader.target scene is referencing this field, whereas this one over here is referencing the unlocal field. So we want to assign the member field to the one that we received as a parameter. Okay, so we stored that, and then let's immediately load the unloading scene. So scene manager, let's load the scene, and we're going to load the scene.loading scene.toString. Okay, so we're going to load that. And now here comes the tricky part. If we do this, so if we load the unloading scene and then immediately load the target scene, if we do it like this, it won't actually show the loading scene. We're calling these functions one right after the other, so it will load one and immediately the other. Basically, we need to wait at least one frame to render so that the unloading scene is visible, and then we can load the final scene. So let's make a script to do a very simple job. Let's create a brand new C# script for the unloader callback. And now let's go inside the unloading scene. So this is important. Let's make this on the loading scene, not the main menu or the game scene. So over here, let's create an empty game object for the unloader callback. Let's reset transform, just keep things nice and clean. And let's attach the script, so the unloader callback, okay. And on this script, we want to basically just wait for the very first update. So let's do a private bool is first update. And we start it off as true, actually. So is the first update is true, then we do a private void update. So if it is the first update, if so, then let's set is first update to false. And we have the first update. Although technically I should point out that we don't really need this. We're going to load right away, so either way it will only run one update, but still I like to add this just to make the logic perfectly clear. Basically, if it is the first update, then let's call a function on the unloader. So on the loader over here, let's make a function, public static void, call it loader callback. Okay, we have this function. So over here on the unloader callback, let's just go into the unloader and call the unloader callback function. All right. So basically now here we have this function that is going to be triggered on the first update. So we know for certain the unloading scene has been rendered. So it's over here that we want to load the actual final scene. Okay, that's it. Here we have a super simple loading system. Just make perfectly sure that the unloader callback with the script, this one only exists on the loading scene. It should not be on any of the other ones. So let's test, and for that, let's go inside the main menu scene. Okay, and now let's hit on play. Okay, so here we are on the main menu. Now if I click on play, and actually here's the thing that I forgot, so make sure you don't forget this. We need to add the unloading scene to the builds in order to be able to load. So let's go up here into the build settings. Let's go into the project, drag the unloading scene like that. Okay, so now let's test. So here we are on the main menu. Let's hit on play, and there's the loading scene. And after a bit, yep, here we have our game scene. All right, awesome. So with that, everything is working perfectly. All of the logic is working great. Now that it all works great, let's just make a nice proper visual for our main menu. So for that, let's go inside the game scene, and over here, let's copy a few things. So let's pick up the floor object, and let's also pick up the global volume with the post-processing. So let's copy both of these. Let's go into the main menu scene, and over here, let's paste both objects, okay? Now let's also drag some player visuals. So let's put this in 3D, go back down to the floor, and let's pick up some visuals. So let's go inside our assets on the prefabs visuals. Let's find over here the player visual. Again, make sure you drag the visual only. We don't want any logic components. And by the way, this is yet another great benefit of separating the logic from the visuals. Right now, it's super simple for us to place some players here because we have just the visuals completely separated from the logic. Okay, so on the visual, let's just make it look at the camera. Let's position a bunch more players. So let's duplicate this and put one to the side. We're going to move the camera in a bit, but now let's just place them. And in the included assets, there are a bunch of materials. So over here, we see the player body. Then we've got a blue, a green, and a red. Like I said, this first course is on making this game in single player, but the goal is to then make a second course after this one on converting this game into multiplayer. So that's why I included multiple colors. So let's just drag these. Let's go into this player visual, and on this one, make it blue. So on the head and on the body. Then on this one on the side here, let's make this one green. So green there and green on the head. And for the one behind, let's make this one the red one. So put it in red and in red. Okay, so we've got our nice 4 players. Now let's also add a camera. So we're going to have the camera kind of like this, kind of from below looking upwards. I think that looks pretty good. For that, let's use Cinemachine. So let's go into Game Object. Go into Cinemachine and let's create a brand new virtual camera. Okay, like this, let's just push it up a little bit. Okay, so this is our nice composition. Now on the virtual camera, let's just go ahead and add some noise. So let's add basic multi-channel purling. So let's do it just like we did when we first added Cinemachine. So let's use the handheld normal mild. And now let's just play around these fields, which by the way, you can do that while the game is playing. So let's hit on play. And over here, you can play around all the fields. Although actually defaults already look pretty good. But let's put the frequency maybe a little bit less and the amplitude maybe a little bit bigger. So just some nice little sway. And by the way, if you make any changes to the Cinemachine virtual camera, and if now you stop playing, it will actually lose those changes. But over here on the virtual camera, there's this nice toggle, save during play. So if you tick this, and now you exit play mode, and there you go, those changes were saved. Okay, great. Now let's just make sure to untick this so we don't accidentally modify it. Okay, so here we have the basic visual that we want. Finally, there's also a game logo in the included assets. So let's just go into our canvas, into our main menu. Let's create a brand new UI image. Let's assign the logo sprite. Then let's just position it on that corner. So let's move it all the way up there. We can anchor it to the top left corner. And let's make it a bit bigger. And by the way, on something like this, if you play around this, it might get a bit stretched. So if so, over here on the options on the image, you can toggle this one to preserve the aspect ratio. So that way, even if you stretch, it won't actually be stretched. It will always be perfect. Okay, just like this. Okay, so here we have our basic main menu. It's a basic setup, but it looks pretty good. And with that, we have built a nice main menu alongside with a loading system. So I can click on play, it goes into the loading scene and then into the game scene, so that's great. The next thing that we need is some kind of pause button, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add a pause button with a pause window that also has the ability to quit back to the main menu, and in doing so, we're also going to solve some sneaky issues with loading. Okay, so here in the main menu, we can click the play button in order to load the game, and yep, everything works, now I'm in the game. But now let's say I want to pause the game for a bit, or quit back to the main menu. Right now there's no way, so let's do that. Let's go here onto the game scene, and first let's enable the pause, and for that we're actually going to need some input. So let's first go inside our player input actions, let's open this, and then over here let's make a brand new action. Let's name it the pause. For the action type, let's go with button, okay, and for the bindings, over here let's go with escape. And actually, if we use the same method that we've been using, if we listen and press on escape, nope, doesn't work because escape just cancels it. So instead, we need to use the search bar here, search for escape keyboard, just like this. Okay, great. Now again, as always, let's make sure to save the asset and wait for the compilation to happen. There it is. So now here on the game input class, let's listen to it and fire the event as usual. So go into the player input actions, the player action map. Let's go into the pause action and listen to the performed event. And when this happens, let's fire off an event. So a public event handler. Let's go on pause action. And then down here, we're simply going to invoke this event. Okay, just like this. Now for listening to it, here's the question, where does that make more sense? Should we do it over here on the player script or perhaps over here on the kitchen game manager? I think over here on the game manager makes more sense since a pause is more related to the game itself rather than a specific action by the player. So let's add it over here. Let's first of all listen to the event. So let's do a private void start, and on start, let's listen to it. So let's go into the game input, and we didn't actually make it a singleton yet, so let's do that. Over here, let's make a public static game input for the instance with a public get and a private set. Then down here on awake, let's set instance equals this. Okay, there's our singleton. So now back in the kitchen game manager, let's go into the instance and listen to the on pause action event. And again, let's rename this to give it a proper name. So this is the game input on pause action. Okay, so here we have it. When we have this, let's call some kind of pause game function. So let's define this. Let's go to the end of the file here. And over here, let's make that function. So a private void, pause game, and over here, we're going to pause the game. Now for pausing, doing this is actually surprisingly easy. Basically, all of our logic is using time.time. For example, over here on the player script, we have our movement